this time, instead of the function f given as a formula, you're given a graph. And you have to read off the values of the graph, values of the function from the graph. And by the way, I've never provided the formula for upper sum or lower sum. That's because it's a bit hard to actually write down what the formula is. It's much better for me to just explain and try to figure that out from the picture. Okay? So that's what I'm intending to do. Okay? All right, so let's start with the upper sum. First, you have n equals to 4, and the interval is from -1 through 7. So what is delta x? What do you calculate? 2. Yeah, delta x is 2, right? It's 7 minus -1 divided by 4. B minus a over n, and that gives you 2. So what are the endpoints then? x0 is here. x1 is +1. x2 is +3. And 5 and 7. Those are the endpoints of the intervals that we're trying to build.
You don't count 0?
Oh, well, you start from -1 and you add a 2 because you're going by subsides of 2. So it skips 0.
Yeah.
Okay, so you have that. All good? All right. Now what we're going to do is we're going to look at these intervals. So we have, this will be our first interval, and then the next one, next one, next one. Just draw it like that. I don't want to draw it too much because it's going to make this graph messy and we can't do the next one. So pay close attention when I try to explain it with the graph. Okay. So for the first construction site, what will be the height of the rectangle that I build if I'm using the upper sum? What do you think?
4.
It goes way up to 5, right? Because that's the highest point. So because we're doing upper sum, we're using the maximum value for each interval. So we see that the upper sum for the very first one will be base length 2. That's the delta x, base length, base times height, and height of what? What's the height of the building that we just built? 5. Okay, now let's move on to the next one. What's the height of the next building?
3.
3, yeah. So it's 2 times 3. Okay, now let's go on to the next one. It's this, no, sorry. It's this one, right? From here until here. So what's the highest point? 3 again. So base times height. How about this last one? It's 2. It's supposed to be 2. Okay. So this is 2 times 2. That will be our upper estimation. 12 plus 22 plus 4 will be 26. Now let's try to do the same thing for the lower sum. For the lower sum, we have the same delta x. So the lower would be base times. Okay, what's the height that you use for the first interval? 3. It's this side that's the lowest in this graph, right? The lowest point of this graph over this first interval is this point. So it's 2 times 3. Okay, what about this one? It's this point's the lowest point, so it's going to be, this will be the rectangle that we built. Okay? So it'll be 2 times 2. How about here? -1. Yeah. Goes down to -1. How about the last interval here?
-1 again.
-1 again. Right? So it's going to be just 6. Okay, let's just try two more. What if we have midpoint, but midpoint from -1 to 7 with n equals to 4. What would that be? M would be still 2 times. In the first interval, what will be the height? 4. It's the midpoint's height, right? And the second one? 2. Third one? 1. Fourth one? 0. Right? So it will be 4 plus 2 plus 1 plus 0. So you have 7 times 2, which is 14. By the way, it's a good habit to count the number of things that you add. You have 4 items added because it's n equals to 4. Same thing here, 4 items. Same thing here, 4 items. For trapezoids, how many would you add?
6.
5. One more. Trapezoid and Simpsons, you have one more. Okay. So let's try to do the following. What if we have D Simpsons for the -1 through 7, but this time n equals to 8. If n is 8, what's our delta x? 7 minus -1 divided by 8, that's 1. Right? So Simpson's rule says divide the delta x by 3. So this 1 is really delta x. And then you put these values, right? The values are like 5 and then 4. The next one is 3, 2, 3, 1, -1, 0, and 2. Those are the values of the functions, but the coefficients change, right? What are we supposed to do? 4 plus 4 times 4 plus 2 times 3. 4 to alternate, right? 4 times 2, 4 times 3, 4 times 1. No, sorry. 4, 2, 4, 2. Right? 4, 2 plus 4. And the last one, you don't do anything. Okay? So you have to compute this. I don't know what this is. Does anyone know? Let's try. 60, 21, 27.
8.
No, sorry.
Oh.
21, 27, and then 8 plus 27, 35, 41, 45, 43, 45, divided by 8. Oh, 6. Okay. So that's Simpsons. And let's just write some. But this time, let's try the interval being 1 through 4 with n equals to 3. Okay, what's our delta x then?
1.
4 minus 1 divided by 3, which is equal to 1. Okay, right sum would be delta x, which is 1, times f of what?
F of
X, no.
Hmm?
No, X1. Right?
Yeah, x1. What is x1 in our case? F of?
F of 3.
No.
F of what?
F of 2. And f of 3. And f of 4. That's it. Okay, so f of 2 is 2, 3, and 1. There's 2 and 3 and 1, so adding, you get 6, so the value is 6. Now, if you're still confused why it's f of 2, look, the interval that we're doing is 1, 2, 3, 4, right? We're trying to approximate this by building 3 buildings, right? And it's the right sum, so what are we doing? We're using the right endpoint of this interval to build the very first rectangle. And the next one is this one, and the last one is this one. Now look at what this is. This is the function evaluated at 2, isn't it? F of 2, which is 2. And the next one is f of 3 and f of 4. Okay, that's why we have that formula. Okay. All right, so hopefully that was good enough. Do you have any questions?